Okay, we're moving on to part B in problem 8. The question is, write an equation for the electric field dE at point P due to the thin slide of the rod dx. Give your answers in terms of blah blah blah. Note that the coordinate x will be less than 0 over the length of the rod. Okay, so basically, let's start off with the equation for the electric field. We learned that electric field is equal to K times the charge divided by R squared, right? Doing this question is exactly the same as just pretending that the charge in this case is just the small dx, the charge in this small dx area, okay? And okay, so now you might be wondering, okay, dx isn't really a charge, dx is a length. However, because of the fact that this rod is uniformly charged, what this means is that the density stays constant, right? So we'll call density rho, and density rho is mass over volume. And in this case, we're not really considering its length. We're not really considering its width because we're assuming that it's a rod, and rods that I don't know, for some reason rods are just considered without width. So that means that instead of volume, we'll just consider the length L of this rod. Okay, so this mass, so every mass divided by the length has to equal to the density. And this applies also, sorry, not mass, charge, because we're dealing with charges, not masses. So this should be charge. Okay, so if we're talking about this small length dx, right, it also follows this rule. So instead of having q, it would be a dq on top, so a small q. D just kind of means small, so small x over small q over small x is also equal to the same density. And this will actually allow us to solve this problem right here. So we know that, okay, so we want to have the charge in this small dx, right? So we can call that dq over r squared, right? And this is the d electric field at that point, the small electric field caused by this small charge in this small area. Okay, well, dq, so we don't know what r, so r, what is r exactly? R is the distance between this thing and the point P, right? That's what r is. But if we want to put it in terms of variables that we actually have, then we could put it in terms of x and a, right? So r is equal to x plus a in this case, right? Because this is x and this is a, and that's going to p. And we also know that dq right here, because of the fact that it's uniformly charged, we can multiply by dx, so this is rho dx right here. And this actually allows us to solve a little integral. So if we just plug in r and plug in x, so this is going to be equal to k times dq, sorry, not dq, so I'm going to plug in q, so this is k times rho times dx divided by, and then plug in r, so r, this is x plus a squared. And the question's asking just write the equation for electric field at dE, so we don't have to evaluate this integral yet. So enter this, so this is the equation you enter to the box. Let me just check real quick, does it have it in terms of rho? If it doesn't have it in terms of rho, in terms of QA, okay, so it doesn't have it in terms of rho right here, but that's fine because we know that rho is equal to just q over the length, right? So just plug in q over length, so then the final answer they should put is k times q divided by length times dx over x plus a squared. Let me just check if that's right. So it turns out I made a little mistake, and the little mistake is that I didn't consider in the question that the coordinate x will be less than 0 over the length of the rod. And what that means is that x is always negative. But what I assumed in this case is that x is a positive number. But if x is a negative number, that's a really simple fix, right? Instead of doing x plus a here, you just do a minus x, right? And that's the exact, if x is a negative number, that'll just be a plus x. So this is a minus x squared. But yeah, and then that gives you the right answer.